Welcome to Algebra 2 CST release question number 81. We are trying to figure out what this is, the quantity 3y minus 1 to the fourth power. So we could think about it this way, 3 minus 1 times itself 4 times. 3 minus 1, 3y minus 1. If I said 3 minus 1, I meant 3y minus 1. We could do that, and then we could FOIL it out, or multiply every piece by every other piece. That's basically what we're thinking. We could FOIL this, we could FOIL these things separately. You could use your shortcut formulas to do that, and then you'd have to multiply all those pieces by all these pieces. You'd end up having 9 different terms doing that, and then you'd combine like terms together after all that. There's an easier way. You should always ask yourself if there's an easier way to do something, and if there is, you might as well do it that way. So hopefully you remember something called Pascal's triangle. If you're new to this though, just listen up here. Here's what we got. So Pascal's triangle looks like this. You start with a 1, then you put 2 more 1s, and you put 1s. You just keep the 1s going down the sides on the diagonals here. But then as you move down in the middle here, you're going to add the 2 numbers directly above it. So 2 would be 1 plus 1. As you move down, put another 1 and 1 here and here. This would be 1 plus 2, 3. 2 plus 1 is 3. Keep that going. Keep that pattern, that idea, that triangle going. This would be 4. This would be 6. And this would be 4. I'm going to do a couple more rows here. Make this one a little skinnier. I'm running out of space here, but 10 and 5. And then this idea is going to keep going. I'm going to stop it here, though, because I don't have forever to keep writing. I'm human just like you. We're all gonna pass away someday. Getting morbid here as I do Pascal's triangle. But back to something more light, a lighter thing. Pascal's triangle. What is this all about? Why is this useful, Mr. Wagner? Why do I care about this for this particular problem? This is your powers right here. It's gonna match up with the power right there. So powers of 0, you can use this row for your coefficients of your terms. Excuse me. For this next one, this would be a power of 1. So not quite there yet. This would be the second power. This would be the third, fourth, fifth, sixth, and so on. And so I'll do this just to keep those things easier to follow. So third power, those are our coefficients. Fourth power, these are going to be our coefficients. Fifth power, these are going to be our coefficients. I'm probably going to refer back to this in some of the future videos, the future problems here. But we've got to the fourth power. I don't have to do all this. This is unnecessary work. I'm going to find the fourth power here. Here it is. These are my coefficients. So I can say that this is going to equal 3y minus 1 to the fourth power is going to equal, and I'm going to fill in the coefficients. I'm going to have 1, and I'm going to have something multiplied together here. I'm going to have, and we do have a minus sign here. We'll consider how that all works out in a second. I'm going to keep those spots blank for right now. But this is going to be a 4, either a plus or minus here. We'll talk about that in a moment. But 4 times something, and then your next one would be 6, that middle coefficient, 6 times something. And then I put a plus sign there. I didn't mean to do that yet. We'll talk about that again in a moment and see if that is in fact a plus sign. Blank spot, and then another 4, just going down the row here. So I've done 1, 4, 6, 4, and I'm going to have one more 1 as a coefficient. So something there, and then plus or minus, and we'll have 1 times something else there. So what gets filled in all here? Just take your first term that you see here. Consider this as the whole first term, 3y. We're taking that to the power of, well, we're taking that to this power first, 4, and then take the other number and raise that to the 0 power. So whatever you have here and here all together, put together, should equal this power. Then as you move down the line, take this one, but reduce it by 1, and then take this power and add 1 to it. So what do I mean by that? I mean this. You're going to have 3y to the third, and then 1 to the first. You're going to have 3y squared and 1 to the second. Notice this 1 really isn't going to make much of a difference, but I just want to iterate or reiterate that that's what it's looking like as you move on. So this might not always be a 1 right there. It might be a little more difficult to deal with. I didn't mean to write a 3 there. That should be a 1 right here, and then this is going to be a 3. So every time going down 1 with the first term, going up 1 with the other term in terms of powers. And then finally 3y. I don't have enough space here. I'm just going to say that this is continuing down here. It's still not going to give me enough space. Try again. So this, and I'll just kind of wrap it around here, plus or minus. Finally, you're going to have the 1 coefficient from right here times 3y to the 0 power and 1 to the 4th power. Ugh, 4th. That's a 4. I promise. There we go. And so what's going in here? As you move down the line, if you have a minus sign, it's a little trickier. If you have a plus sign right here, everything's positive. There's not going to be any negative parts. But if you have a minus sign, the odd-powered parts should be with a negative coefficient. So this will be positive because you'd have 3y to the 4th, and that's going to be this other part. When you all multiplied it all, or when you multiplied it all together, you would end up getting a positive coefficient here. Not going to get into more details beyond that, but just know the even powers should have positive coefficients if you have the minus sign here. And then the odd powers, it's just going to flip back and forth. Odd powers, minus sign, even, back to positive, then negative, and then finally back to positive. So let's put all this together. Let's figure out what all this is. 1, no change there. 3y to the 4th, that's the same as 3 to the 4th, which is 81, and y to the 4th, which is just y to the 4th. 1 to the 0 power is still going to be 1. That's not going to change anything there. So here we've got minus 4. I'll keep that on the outside and simplify the inside. 1 to the 1st, again, all these are going to end up being 1 here. So I just really need to think about the 3y to the power part. 3 to the 3rd is 27. Y to the 3rd, y to the 3rd. Here, plus 6 times 3y squared would be 9y squared. Or I should say more properly 3y squared, the whole thing squared. And 1 squared is still going to be 1. That's not going to change that at all. So we'll have this minus 4 times 3y to the 1st is just going to be 3y. And then you'll have that plus 1 times in here 3y to the 0. Again, anything to the 0 power will be 1. You'll have 1 times 1, which will just be a 1. So to simplify this, to complete the problem, you've got 81 y to the 4th minus, this will be 108 y to the 3rd plus 54 y squared minus 12y plus 1. Your final answer for number 81 should be choice A.